vastness of space is populated by millions of stars, clouds of glowing gas, and patches of obscuring dust, which are grouped into systems called galaxies. Our own galaxy is so vast that it would take 100,000 years to cross it, even traveling at the speed of light. Beyond our system lie countless other galaxies. They take many different forms, but about half of them reveal a spiral structure. Our galaxy is a typical spiral, containing about 100,000 million stars distributed along the spiral arms and in a dense concentration at the central nucleus. When we look at the night sky, we see this multitude of stars as a faint band of light, which we call the Milky Way. The techniques of radio astronomy have been used to map the spiral structure of the Milky Way system. Our sun is merely one of the millions of stars in our galaxy. It lies far from the center, surrounded by its attendant bodies, the planets and their moons, comets, meteors, and asteroids. This complex we call the solar system. The sun is an ordinary star composed mainly of hydrogen. The second most abundant element, helium, accounts for less than 10% of the total material. The visible surface, or photosphere, is surrounded by the chromosphere, so called because of its pinkish color. The chromosphere is seen here during a solar eclipse, as the moon completely obscures the sun's blinding disk. The photosphere has a temperature of 6,000 degrees Celsius, and at the core, the temperature of the sun is thought to reach 14 million degrees Celsius. Here, thermonuclear reactions convert hydrogen into helium to release energy, which is slowly transported towards the surface by radiation. At a certain point, however, this radiative process breaks down, and the energy is carried by convection to the photosphere, passing through the chromosphere and into the corona. Magnetic fields stretch out from the photosphere into the corona. This produces sunspots in the photosphere and prominences in the chromosphere and lower corona. From the manned space laboratory Skylab, astronauts, clear of the obscuring atmosphere of the Earth, were able to photograph the sun with special equipment. This X-ray emission picture revealed bright, jewel-like points of light, which are a manifestation of the sun's magnetic energy. Observations were also made of prominences and flares, eruptions on the surface of the sun. Time-lapse photography, which speeds up motion, shows how filaments of hot gas are violently ejected thousands of kilometers above the solar surface. From these eruptions comes the solar wind, streams of fast-moving protons traveling outwards from the sun. Because of the sun's rotation, they appear to travel in a spiral path. With a diameter of 1,390,000 kilometers, the sun contains 99.87% of all the material in the solar system. Most of the remainder is concentrated in the 9 planets. The planets are thought to have formed from a disk of hot gases revolving around the sun. As the gases cooled, elements began to condense, and masses formed by accretion pulled in more material by gravity. At this stage, the first planets suffered collisions and bombardment by meteors and asteroids, and their surfaces became scarred with craters. Our own moon still bears the evidence of this period of planetary formation, which came to an end about 4,000 million years ago. By that time, most of the original material had been swept up and a stable planetary system had been established. There is one region of the solar system, however, where planetary debris still circles the sun. Between the orbits of Mars and Jupiter lie the asteroids. Here the combined gravitational forces of the sun and planets have worked against the formation of a large planet. Compared with the Earth, these asteroids are small bodies. The largest is only about 1,000 kilometers in diameter. There are many comets in the solar system, moving in closed elliptical orbits. The most famous of these, shown here on the 11th century Bayeux tapestry, is Halley's Comet, which returns every 76 years. Other comets are thought to circle the sun far beyond the 9 planets. Occasionally, one of these is disturbed from its orbit and makes a close approach to the sun. It may develop a tail, which will always point away from the sun, driven outwards by the solar wind and the pressure of sunlight. Because of this, the tail precedes the comet as it moves away again. Comets are tenuous bodies. The tail is an extremely rarefied gas, and the head a cluster of fragments of frozen gas and dusty ice. Interplanetary space also contains many meteors, tiny rock and metallic objects, which travel in swarms around a definite orbit. Every year, the Earth passes through several of these meteor swarms. Some enter our atmosphere and burn up, making a spectacular display which appears to radiate from a particular point in the sky. The planets of the solar system are usually divided into 2 groups: the inner planets, Mercury, Venus, Earth, and Mars, and the outer planets, at increasingly vast distances from the sun: Jupiter, Saturn, Uranus, Neptune, and Pluto. The orbits of the planets lie in roughly the same plane, the plane of the ecliptic. This is considered to be evidence of their origin from a disk of gaseous material. The exception is Pluto, whose orbit is tilted 17 degrees. Physically, the inner or terrestrial planets differ from the outer planets in several ways. Mercury, Venus, Earth, and Mars are all small and dense, with a crust, mantle, and a metallic core. The outer planets, except Pluto, are large, low-density bodies. This cross-section of Jupiter shows the gaseous atmosphere of hydrogen, ammonia, and methane. Below this is a layer of liquid molecular hydrogen. Further down, under the enormous pressure, the hydrogen is in a liquid metallic form, which does not exist on Earth. At the center is the small, heavy core. Saturn, like Jupiter, has a gaseous atmosphere merging into a layer of liquid molecular hydrogen. Below is a layer of liquid metallic hydrogen, though not as large as Jupiter's. Its rocky core is surrounded by a layer of ice. The mean density of Saturn is less than that of water. Uranus and Neptune both have large ice shells, but no metallic hydrogen layer. Of the terrestrial planets, only the Earth and Mars have moons, but the Jovian planets all have multiple satellite systems. Pluto has 1 small moon discovered in 1978. The major satellites of Jupiter, Saturn, and Neptune are similar in size to the terrestrial planets. The relative sizes of the Earth and its moon, and of Pluto and its moon, suggest that they should be considered as double planetary systems. Early planetary astronomy was concerned only with recording and predicting the positions of the 5 known planets. These were regarded as moving in crystal spheres against a background of fixed stars. The introduction of the telescope by Galileo led to a great expansion of knowledge. With his instruments, he discovered the craters of the moon, sunspots, and the major satellites of Jupiter. Improved telescopes led to the discovery of Uranus and Neptune, and finally in 1930, the planet Pluto was detected. The era of spaceflight has brought a great flood of new knowledge. Men have walked on the moon, and unmanned spacecraft have given us a truer picture of conditions on the strange and varied worlds of the solar system. Mercury, smallest of the terrestrial planets, is also the closest to the Sun. It was first investigated by a spacecraft in 1974, when Mariner 10 photographed its surface. Pictures like these revealed it as a world very much like our moon. There are densely cratered highlands and vast plains with relatively few craters. Calculations suggest that it has a large metallic core extending perhaps 2/3 of its radius. It is a planet without water and with virtually no atmosphere. If we could visit Mercury, the Sun would appear very large in its sky. The planet circles the Sun in 88 days and turns on its axis so slowly that one day from sunrise to sunrise takes 176 Earth days. So Mercury's day is twice as long as its year. Before the age of spaceflight, Venus was a cloud-covered mystery. Nothing was known about surface conditions, and even its rotation period was not established. This picture, secured by the Pioneer Venus orbiter, revealed flow patterns in the clouds. The spacecraft then made a radar scan of Venus, and it now appears that over half the surface is relatively flat, varying in height by only about 1 kilometer. The largest highland region, given the name Terra Aphrodite by American scientists, is half as large as Africa. A smaller highland area, named Terra Ishtar, is the size of the United States. Both areas seem to be fractured and faulted. Two giant volcanoes have been detected, and there appear to be a great many impact craters. This suggests that erosion of the surface is not significant. The lowest point is a rift valley about 3 kilometers below the mean surface level. Earth-based radar established that Venus turns once on its axis in 243 Earth days. The atmosphere of carbon dioxide exerts a pressure about 100 times that of the Earth's, and the surface temperature appears to be about 480 degrees Celsius. Continuing our journey outwards from the Sun, we next encounter the planet Earth. From space, it would be immediately apparent that the Earth has an extensive atmosphere. Clouds cover about 50% of its surface. Instruments would reveal them to be composed of water vapor and water ice crystals. We would also be able to see the polar caps and to observe their growth in the winter and shrinkage in the summer season. Through the clouds, it would be possible to map the permanent surface features, the continents and oceans. Seasonal variations in color would indicate the presence of vegetation. The almost complete absence of large impact craters would show that erosion by water is a powerful force in Earth's geology. Even the presence of intelligent life could be inferred from the radiation of energy from certain regions. With the planet Earth, we encounter the first natural satellite, the Moon. With a diameter a little over 1/4 of the Earth's, its size compares with the planet Mercury. The Moon has no atmosphere and no water. The specimens of lunar rock brought back by astronauts were all much older than any found on Earth, between 3 and 4.5 billion years, not because the Moon itself is older, but because it is a completely dead world, and the rocks have remained unchanged. Clearly, the craters have been formed by the impact of objects crashing to the surface. The lunar soil seems to consist of pulverized material down to a depth of several kilometers. Instruments left by Apollo astronauts have recorded moonquakes from deep within the interior. The shock waves reverberate for almost an hour before dying away, indicating that there is no firm bedrock. Gravity is only 1/6 of Earth's, a fact evident as we watch Apollo astronauts moving about on the surface. Mars is the only planet in the solar system that even remotely resembles the Earth. It has a day of about 24 hours, and its axial tilt is similar to the Earth's. It therefore has seasons like Earth, though they last twice as long, because Mars takes almost 2 Earth years to circle the Sun. One obvious manifestation of seasonal change on Mars is the forming and melting of ice at the poles. The polar caps contain water ice and frozen carbon dioxide. These views of the surface of Mars were obtained by the Viking lander and show that the name Red Planet is very appropriate. The redness of the soil is attributed to oxidation of iron-rich material. Though Mars's atmosphere is extremely thin, dust storms are a common occurrence and have even been observed from Earth through telescopes. This picture from the Viking orbiter shows a dust storm indicated by an arrow which is 300 kilometers across. The whitish region at the bottom of the picture is the outer edge of the polar cap. Mars boasts the largest volcano so far observed anywhere in the solar system, though it is extinct. Olympus Mons is 2.5 times the height of Mount Everest and measures 600 kilometers across its base. In this photograph, only the summit can be seen above a layer of clouds composed of water ice condensed from the atmosphere as it moves up over the volcano. Here, ancient lava flows have congealed where they cascaded over a cliff surrounding the volcano. One of the most astonishing features is a great canyon, which cuts across the planet for 5,000 kilometers and is longer and deeper than the Grand Canyon on Earth. This composite photograph shows a landslide where the far wall, which is about 2 kilometers, has repeatedly collapsed. There are many meandering channels which are strongly suggestive of dried-up riverbeds. Although there appears to be no surface water on the planet now, some may exist locked beneath the surface in the form of permafrost. Looking at these photomosaics taken by an orbiting spacecraft, it is impossible to resist the thought that water once flowed here in rivers and tributaries. Once again we encounter impact craters on a planet's surface. Mars's 2 tiny moons are also scarred with impacts. To us, Mars appears bleak, cold, and airless. But one day men will set foot there and may even establish settlements with cities under pressurized domes. The giant planet Jupiter orbits 778.3 million kilometers from the Sun. The surface we see is streaked with parallel cloud belts. A prominent feature is the Great Red Spot, which has been observed for 300 years. It is thought to be an enormous cyclone. Jupiter has at least 16 moons, the 4 largest of which were discovered by Galileo in the 17th century. This Voyager photograph shows 2 of them against the planet's disk. Beyond the right-hand one, the Great Red Spot can be seen. Callisto, the outermost Galilean moon, is completely surrounded by an ancient frozen sea. Its icy surface is crowded with craters. It was continually struck by meteors and asteroids in the early period of planetary formation. Ganymede, Jupiter's largest moon, is probably composed of an equal mixture of rock and ice. It has fewer impact craters than Callisto. This suggests that its surface was still in a liquid condition at the height of the bombardment era. Europa, smallest of the Galilean moons, appears to have a relatively smooth surface, though many fractures crisscross its frozen wastes. The surface must still have been liquid after the meteors rained down. Io, innermost of the Galilean moons, presents an astonishing appearance. Its surface is torn by violent volcanic eruptions. In this photograph, a volcano can be seen in action on Io's rim. matter is being hurled upwards to an altitude of 300 kilometers. The terrain is a mixture of brightly colored sulfur compounds brought to the surface by volcanic activity. Io has been literally turned inside out. Voyager 1 discovered the existence of a faint ring surrounding the planet Jupiter. In this photograph, it has been outlined to indicate its position. Bright-ringed Saturn is the most splendid planet in the solar system. The rings are not solid, but are composed of many separate fragments of ice mixed with dust. The average diameter of the icy rocks varies from ring to ring. Voyager 1's encounter in 1980 produced this splendid series of pictures and resulted in much new knowledge. On a previous encounter in 1979, Pioneer 11 had discovered a new ring of Saturn, the thin F ring. Voyager 1 discovered 3 new moons of Saturn, 2 of which orbit in the gap between the A ring and the F ring. This photograph shows the outer F ring clearly. Close-up photographs like these show that the rings themselves are divided into over 1,000 thinner ringlets. Titan is Saturn's largest moon. It is completely covered by an orange haze which floats in an atmosphere of nitrogen. There may be rivers and glaciers of methane on its surface, while the temperature is minus 180 degrees Celsius. Computerized color pictures reveal the layering of the atmosphere, where compounds such as acetylene and hydrogen cyanide have also been detected. The smaller moons of Saturn are composed mainly of ice, but ice so cold that it behaves like rock. This photograph is of Rhea. A closer view of the most heavily cratered of Saturn's moons indicates that it is probably one of the oldest bodies in the solar system. Dione, seen in this photograph against the face of Saturn, shows streaks and a dark area like the markings on our own moon. In a closer view, hundreds of craters are seen. Dione contains 40% rock. Mimas has long troughs 5 kilometers wide. On its opposite face, a huge crater a quarter of the moon's diameter was seen. From one of its nearer satellites, Saturn would present a most impressive appearance. Before leaving Saturn, the spacecraft's camera obtained this spectacular view of the backlit planet. Beyond Saturn, we are entering a region of the solar system that holds many mysteries. The planet Uranus rolls in its orbit, its axis tilted 98 degrees to the plane of the ecliptic. The orbits of its 5 small moons are tilted at the same angle, so they orbit around the equator of the tipped-up planet. In 1977, it was discovered that Uranus has a system of rings. Though normally invisible from the Earth, their existence was discovered when Uranus passed in front of a star, and obscurations of its light were accurately measured. The fourth and outermost of the giant planets is Neptune, lying at nearly twice the distance of Uranus from the Sun. It takes nearly 165 years to complete one orbit. The strangest thing about Neptune is the behavior of its 2 moons. Triton, the largest moon in the solar system, orbits in a retrograde or backward direction, and the small moon Nereid traces an elongated ellipse which carries it far away from the parent planet. Pluto's orbit is tilted at 17 degrees to the ecliptic and is so eccentric that the planet comes closer to the Sun than Neptune from 1979 to 1999. facts which have led to suggestions that Pluto is in reality an escaped moon of Neptune. One theory is that Neptune originally possessed 4 moons revolving in normal orbits, and that a massive body once passed through this remote region of the solar system, disturbing the gravitational balance. This rogue planet first reversed Triton's direction, flung Pluto and Charon into a planetary orbit, and then sent Nereid into its wild elliptical path before moving back out into the depths of the solar system. We have no way of knowing whether this actually happened, but it's certain that Pluto is a very strange world. It appears to be composed of frozen gases, and its density is half that of water. Methane frost has been detected on its surface. Its moon, Charon, discovered in 1978, is half the diameter of Pluto, and orbits in the same time that Pluto takes to rotate around its axis. It therefore remains perpetually over the same region of the planet. In the skies of Pluto, the sun would be merely a brilliant star, and the Earth could never be seen or its existence suspected from this vast distance. This, then, is our solar system. From what we know now, it appears that within it, our Earth is unique. No other planet or satellite seems capable at the present time of supporting life. But it is likely that elsewhere in our galaxy, and in the other galaxies beyond the Milky Way, there are many stars with their attendant planetary systems. And perhaps in some of these, there are other planets like the Earth, which support rich and varied forms of life.